So with that done, we have about 20 minutes remaining, and that's probably good amount of time to keep playing with the ChatGPT. And this is, something that I think might be helpful to you in the sense that this is an actual demo of things that I think is totally okay or even encouraged, recommended for students to do. So I think next week I'll be doing timed assessments on demo. And when I do some demos of multiple choice timed assessment, I will do something that I will tell you is like cheating. You shouldn't do it. It's not a demonstration of anything you should do. That's next week. But what I'm doing this week is it's a kind of a demonstration of how you might use generative AI in a way that's academically honest, in a way that helps you learn. So, basically, and let me just... Test student is my worst student. He never does anything he doesn't feel he needs to do. So that's why these haven't been cleared yet. But I'm in the part of the semester where my worst students can just skip through material real easily. But, the demo I'll be doing today with the ChatGPT won't be, what my worst student would do, but what my, average student might do. Or what my model student might do even as they are trying to learn. Because I guess the model student doesn't mean they know everything already. It means they are learning. So here's ChatGPT, and in the 15 minutes or so that we have, let me just pick out a few questions and work through them in interacting with the ChatGPT, how typical student might, and I'll try to come up with some mistakes that I've seen people make. And I will I will get help from ChatGPT to fix those mistakes. And I find that it's useful to condition or pre-condition ChatGPT so that it doesn't just solve all your questions for you. That's really not going to be any help in the long term. So let me give ChatGPT a set of instructions to make sure it doesn't just give me answers right away. It probably already has it retained in its memory a little bit, but I find it useful to just start with that instruction anyway. Hi, I'm working on my electrostatics homework, and as before, I am really trying to make sure that I learn the material. I need to be prepared for the oral exam in a few weeks. So I'll give you the questions. Please don't tell me the answers or all the solution steps right away. Wait for me to tell you what I have done so far and just help me with the next step. I want to make sure that I am learning the material. So with that, let's find, and it knows my name because of memory. For a while it was calling me Andreas because I told it that my name is Andreas from when I was trying to practice German. I'm not trying to practice German anymore, but I corrected it to Andrew. It's not calling me Andreas anymore. So yeah, I think let me try to find some of the harder questions. Ones where you can just do with the formulas. I think those are easy, like these ones that I just did. Separate video clip. This is a good one. Did I already do a version of this? Oh, I did it for electric field, I think, with the ChatGPT, I mean. So here, I could do this with the ChatGPT. I wonder if there's a different geometry. Yeah. I think this could be useful. Although technically, it's one of those things where if you have the right formula, then you can get it pretty easily. Like these are the right formulas, but Oh, maybe let's do it this way. Maybe suppose you are not familiar with the partial derivatives. You should be learning them in Physics 4C, which is co-requisite with this class. But let's say, for whatever reason, you are not familiar with the partial derivatives. So I'll lead with how do you take a partial derivative? Let me see if it'll explain. It's actually easier than total derivative. You just take the derivative with respect to the variable, assuming everything else is constant. So differential multiple with respect to one variable while treating the other variables as constants. Yep. That's the potential free dx. Oh, that sounds easy. Let's see. Does it then do the? Oh, yeah. So I don't know. I think it's probably unrealistic. So let me try this. While saying I think it's unrealistic for people to make mistakes, but maybe sometimes people do. So one mistake someone could make is do something like this. So taking derivative, you forget that the things that are constant goes to 0. So you do this, and then you tell it, oh, it says it's wrong. Plus 4xy squared. So it'll say it's wrong, and then I'll ask. But this is actually one way in which generative AI is better than my homework help videos. With the homework help videos, if you try to follow the steps and you get it wrong, videos can't answer your questions. You can ask the video, hey, what am I doing wrong? I mean, you can ask me and I'll usually respond within a day, but it's not an instantaneous reply. Why is it, so I'll say, why is it saying it's wrong? Hopefully ChatGPT will correct me that the constant terms should go to 0. Oh, I'm surprised. Well, so it's possible this is ChatGPT just trying to be helpful, not giving me the answer right away, I think. So let me just say, for number 1, my answer is in the screenshot. Can you read it? If I can't, then I can type it again. Yeah. Wait, did I write that? No, I think it's misreading G as X, which is fine. Actually, this font is super confusing. I was actually reading it as X with my bad eyesight before. Yeah, and I'm pretty sure it actually is misreading that from the constant. So, yeah. Yeah, it's but let's do this. The potential is V is equal to minus G squared plus 4x y squared. Yeah, wow, that really looks like an X. So yeah, so it gives it that, and wait, that's wrong. It's plus still. Oh, I forgot the minus sign. You'll see me make that mistake multiple times. I don't know. I think I'm just used to doing the absolute value thing to avoid the sign errors. So I keep making the sign error. So that's actually right. So EY, and hopefully as you are reading it, you realize, oh, that the first term is wrong, and I made a sign error. And the EG minus, oh, therefore, yeah, sign error. That mistake was totally unintentional. It's just, like, I might be making the mistake on other homework help videos from time to time. I do try to correct it. If I can't correct it within the session, I will put a text title somewhere so that you can see it while you are watching the video. Yeah, I got it. Thank you. So I think we have enough time for maybe one more question. Let me see if there isn't a substantially difficult question. More difficult than this, I might come back to this. I think this is, well, this could be good, but let me see, look at other questions. Yeah. So I think this is a good question. So it's multi-part, and so this is basically a more complicated version of this. The way you answer this is kind of treating as a limiting case of, was it 7? Yeah, this where the outer this radius, 5 centimeter, goes out to infinity. So you have just single charged conductor here. The other larger conductor that helps to make net charge 0 is just out at infinity. You get a finite capacitance with that. So let me do this one. I think I need to take screenshot in 2 steps. It's too long vertically. Okay, I have this question, and I think A is 0. That's all I have so far. So the question there, and then A, B, C, D. It'll probably confirm that A is correct, and let's see what it does with the B, C, D. It might give me the first step to do, and then and then we'll take it from there. Yeah, okay, good. And you can multi-parts, you can do one question at a time. The other ones, you won't use up your attempts. To the extent that it matters, you get practically infinite attempts. So A is done. B, so that's interesting. You can definitely do it this way. I think in my homework help video, I probably did the integration of electric field. But this is another valid way to do it. Use the principle of superposition, which a lot of you learned about in the lab session this week. And so, yeah, due to charges at any point on its surface is a surface. Oh, spherical shell. All right. So I will show you one possible misuse of this formula. That'll nonetheless give you the correct answer for B, and I think the correct answer for C. So let me do that misuse of the formula. The thing is, it didn't really, but it's fine because it says charge the sphere at any point on its surface. So when you are dealing with this shell, then it's not really the so it's the surface for these negative charges, but it's not the surface for the positive charges. But if you misapply, you'll still get the same formula. So you would say something like, let's see, V total is equal to charge, the potential to the inner thing. So that'll be K times plus Q divided by, now here if we use the wrong radius of this inner sphere, then you'll get the wrong answer. But if I use the radius r of the actually, let me try that. So for B, let's see, so let me do it this way. So this is one way of misapplying the formula that will give you a wrong answer. So I could say for B, V total is because it mentioned the superposition, so I'll do K plus 5 microcoulomb divided by, and I'll use the wrong 2 centimeter, and then this plus, let me just move this a little bit to the right so I have space to write. KE, and then it's minus 5 microcoulomb, right? I'll double check after writing. And then you could use 5 or 6 centimeter. Let me use 5 centimeter. Both are wrong. Let's see. Yeah, it's plus 5. Okay. So I'll say, how does this look? How does this look? And then it's going to do to a charged object. Yeah, somewhat that's good. And then it potential at, yeah. So you have to use the however far it is. And charge on the put it on the surface, so the charge is that, yeah. Good. Oh, they cancel out. So if you had misapplied, I still argue it's a misapplication of the formula, but maybe it's not. It's a little harder to argue that when you still get the correct answer. So for the PHYS, what do you think the potential of the sphere itself will be? So I'll say, is it 0 again? V total is equal to KE plus 5 microcoulomb divided by 2 centimeter plus KE minus 5 microcoulomb divided by 2 centimeter. Let's see how it will correct me. It should say the contribution from this, you cut it off actually at 6 centimeters. Only the charges sphere itself, which, oh, it might not never get it right. Because you have to basically account for an offset. It's possible the ChatGPT doesn't know how to do that. So I'll put in the answer. Well, use all from alpha. Coulomb constant times 5 microcoulomb divided by 2 centimeters. So it'll give me something in volts. I'll put in 2.247 times 10 to the 6. 2.247 is 10 to the 6. Okay. Yeah, it'll say that's wrong. Oh, wait. So I'll say I plug in the numbers and the system says the answer is wrong. Sometimes the ChatGPT is able to correct itself once you tell it it's wrong. Sometimes it corrects itself when it's not wrong, if you try to gaslight it into thinking that it's wrong. Gonna get the same number, but once it gets to that, it might say I tried a couple different ways. I think the number itself is wrong answer. Yeah, it's a surface. No, that wouldn't be the reason. Sphere called shell is at 0 volt. Yeah, there's another fact. Sphere takes into account yeah, that is actually right. Not just this, the shell will influence the result. Okay, can you help me in figuring out the influence of the shell? I'm trying to see if it'll use the correct radius, 6 centimeter. So when I do this, it won't be right, but I can tell ChatGPT something to make it feel better. Oops. So I'll just say minus 5 microcoulomb divided by 5 centimeter. That'll give me wrong answer. Or it might be still be graded as correct. We'll see. 1.348. It's still graded as correct. Because the correct, or you know what? I think that's actually right. Sorry, I misspoke. These negative charges, because of these positive charges, they'll be distributed on the inner shell, not the outer shell. So yeah, that's actually correct. Yeah. So I'll say I got 1.348E6 for C, and the system says that's correct. For D, is the answer 0 again? It's not. It should be same as C. Yeah, it's not. yeah. So yeah, that's the correct answer. Yeah. So yeah, it's so I think this I'm almost willing to call this a feature, not a bug. The fact that sometimes it'll give you wrong answer. So you know, so like here, you know, so where it's answering it. Like this answer, it's wrong, but as you're working through it, like sometimes, you know, when you're working with a tutor, even good to decent tutors, it will sometimes make mistakes. But a tutor who is good, once they realize an answer is wrong, they should be able to figure out what corrections that they need to make. And I've seen ChatGPT do that. Once you tell it, oh, that's not the correct answer, then it's like here, you know, I didn't give it any additional information, and it's able to actually come up with the corrections itself. And I still argue, you know, it's a large language model. I don't think it thinks for itself, but however the algorithm works, it, you know, on several repeated passes of the same problem, it's able to come up with the correct answers. Sometimes, you know, even the ones I missed, or going with different radius, but I don't know. It might have guessed the 6 centimeters if you tell it 5 centimeters wrong. So anyways, I think that's everything. We are over time. Thank you to both those who are here in real time and those who may be joining by recorded the video. Let me say goodbye to people joining by recorded the video. And I'll stay online briefly after stopping the recording, which is what I mean by saying goodbye to people joining by recorded the video. Bye.